We're going to talk about what it takes to design a good printed circuit board. You're not routing signal traces. You have to think about routing transmission lines. And in this case, you really want them to be good transmission lines. That means that the entire length of the switched conductor is only one dielectric from the unswitched conductor or ground. This dielectric can be between layers, or it can be side by side in the case of a low layer count board. The example we're going to talk about is aimed at a two-layer board. Each layer has to be considered as if it was a single layer by itself, routed intact, and then when you want to move energy from layer 1 to layer 2, you have to provide the z-axis transmission line for the energy to move from the horizontal dielectrics in layer 1 to the horizontal dielectrics in layer 2. While this is a scenario that will not allow you to have any type of high speed or high energy delivery, it will provide a reasonably good space for these traces separated from each other and have a real transmission line. This also is the approach you need to take if you have a layer that's not directly next to a ground plane. So in the case of a 4-layer board with one ground plane on layer 2, layer 4 must be routed as if it were a single layer, with coplanar ground next to each signal or power trace, and then a z-axis transmission line with a signal or power via next to a ground via that will allow the energy to have a captive space to move through from the top dielectric pairs to the single layer by itself. Most important signal on every board is the power distribution network. So the power conductors are extremely important, and they must be intact transmission lines from the place where the energy arrives on the board until you finally use it to do some type of work. Again, this ideally would be a trace routed over a ground plane, or in the case of higher energy movement, you would want fairly wide traces to reduce the impedance of the transmission line, or use parallel transmission lines to carry the energy. The idea, though, is to reduce the volume of the power transmission lines and to reduce the distance the waves have to travel as they go from the source of energy to the IC where you want to switch and redistribute this power.